Hey, how's everything going? My name is B.Nava, and my project poster, Sectoral Vulnerability Affecting Climate Change Readiness Using Statistical Analysis, contains a lot of information, so we're just going to go ahead and break it down one section at a time. Now, all countries to a different extent are facing the challenges of climate adaptation. Due to geographical location or socioeconomic conditions, some countries are more vulnerable to the impacts of climate change than others. This study examined sectoral vulnerability across 10 key areas using statistical methods to determine where resilience is weakest. I applied descriptive statistics, one-way analysis of variance tests, Tuckey's honest significant difference post hoc test, and correlation analysis to uncover significant differences and interrelationships. Key findings show adaptive capacity as the most resilient sector and infrastructure as the most vulnerable. In this context, adaptive capacity is the ability of society and its supporting sectors to adjust to reduce potential damage and respond to the negative consequences of climate events. My primary research question, are there significant differences in vulnerability among sectors, was answered with strong statistical support. These insights may inform targeted interventions and policy prioritization. Now, before moving forward, I want to highlight the countries that are displayed on the map below. After determining the 20 most vulnerable countries, I was able to place them on the map to help better visualize the countries that I will be mentioning going forward. The Notre Dame Global Adaptation Initiative's Country Index, or NDGAIN for short, is a free open source index that shows a country's current vulnerability to climate disruptions. It also assesses a country's readiness to leverage private and public sector investment for adaptation actions. The index brings together more than 40 core indicators to measure vulnerability and readiness of 182 UN countries from 1995 to the present. The NDGAIN Country Index summarizes a country's vulnerability to climate change and other global challenges in combination with its readiness to improve resilience. It aims to help governments, businesses, and communities better prioritize investments for a more efficient response to the immediate global challenges ahead. A country's NDGAIN index is composed of a vulnerability score and a readiness score. Vulnerability measures a country's exposure, sensitivity, and ability to adapt to the negative impact of climate change. NDGAIN measures the overall vulnerability by considering vulnerability in 6 life-supporting sectors: food, water, health, ecosystem service, human habitat, and infrastructure. For this project, I focused primarily on the overall vulnerability score when choosing my countries of focus. The plot is divided into 4 quadrants, divided by the median score of vulnerability across all of the countries and overall years, and the median score of readiness calculated the same way. Now, we can see some examples of the country profiles found in the index on the left side of the screen. And if we take a look at the scatter plot on the bottom right, we can see that approximately half of the countries fall to the left of the readiness median and half to the right. And similarly, half fall above the vulnerability median and about half below. Now, our dataset contains vulnerability scores for 10 key sectors essential to societal and ecological well-being, the 10 sectors being adaptive capacity, ecosystem services, exposure, food, human habitat, health, infrastructure, sensitivity, vulnerability, which is overall vulnerability, and water. Now, these scores reflect how exposed or resilient each system is, based on a scale from 0, being least resilient, to 1, most resilient. Now, the data is quantitative and continuous, which allows for direct comparison across sectors. Now, although this dataset is anonymized and the source methodology is not fully disclosed, we assume it was compiled using expert evaluations, composite indicators, and international development metrics. Now, the reliability of this data lies in its consistency and its relevance to cross-sectoral risk analysis. So, before conducting any statistical analysis, I first had to import and clean the data from any occurrences of NAs, since I was comparing each country across every sector. Now, once removed, I selected the 20 most vulnerable countries according to their overall vulnerability scores. I then followed these analytical steps. I began with my descriptive statistics, calculating the means and standard deviations to summarize each sector's vulnerability. I then did a one-way ANOVA test, testing for significant differences between sector means, my null hypothesis being that all sectors have equal mean vulnerability, and my results were significant. Then a Tuckey's honest significant difference post hoc test to identify which sector pairs were significantly different. I then did a correlation matrix to measure how sector vulnerabilities covary within one another. I then created a handful of visualizations using bar plots, heat maps, and clustering to enhance interpretation. Now, all these steps were done to ensure both statistical validity and interpretation clarity. Now, here we can see that adaptive capacity and health emerged as the most vulnerable sectors, whereas infrastructure and sensitivity showed the lowest average vulnerability scores. Now, the whiskers being displayed on top of the bars, the graph above, show the standard deviation of each group. The bar graph below corresponds with the whiskers above. Now we can see that water and infrastructure show the highest variability, standard deviations of 0.123 and 0.116 respectively. Vulnerability has the lowest standard deviation of 0.0347, suggesting that it's a composite score with less variation. Now for this study, I used a one-way analysis of variance test, or an ANOVA test, to test whether the mean vulnerability scores differ significantly across sectors. Now the sectors being analyzed included food, water, health, ecosystem services, human habitat, infrastructure, adaptive capacity, exposure, sensitivity, and overall vulnerability. Now we can see that our F value is given as 44.92. Now this is the ratio of between group variances, which is the differences between sector means, compared to the within group variances, which is the variability within each sector. Now, F value of 44.92 is considered a high F value, which suggests the group means are not all equal. Now, this can be seen by the graphic above, showing each sector's mean and the amount of occurrences that happen around that mean. Now, we can clearly see that each sector has a very different, not only mean, but the amount of occurrences that happen within and around that mean. Now, the p-value is given as basically 0, which is an extremely small, much smaller than the typical threshold of about 5%. Now, this indicates that the observed differences in mean scores are statistically significant and unlikely due to chance. Now, the ANOVA results show highly significant differences between the sector scores. Now, this justifies the use of a Tukey's post hoc test to determine which specific sector is different from one another. Now, after the ANOVA test confirmed that mean vulnerability scores differ significantly across sectors, a Tukey's honest significant difference test was used to pinpoint which specific pairs of sectors differ. Now, the printed output gives confidence intervals and adjusted p-values for each sector pair comparison. The plot visually shows whether confidence intervals for mean differences cross 0. Now, if they don't cross 0, the difference is statistically significant. Wider intervals indicate more variability in the comparisons. For example, adaptive capacity versus infrastructure had a large negative difference, approximately negative 0.37, with a p-value of far below 5%, meaning that infrastructure was significantly less vulnerable. Now, when we look at health versus adaptive capacity, they had no significant difference. Their p was approximately 0.94, which suggests similar average vulnerability. Now, this test confirms many sector pairs differ, especially those involving adaptive capacity, infrastructure, and water. I then computed a Pearson correlation matrix to assess the linear relationships between the vulnerability scores of different sectors. Now, each sector represents the correlation coefficient between two sectors, positive being blue, negative being red, and no correlation being white. Now, a couple strong positive correlations would be vulnerability with water at 79%, vulnerability with sensitivity at 75%, and vulnerability with food at 70%. Also, adaptive capacity with food at 44% and adaptive capacity with vulnerability at 56%. Now, a couple negative correlations to note would be human habitat with infrastructure at negative 44%, sensitivity with exposure at negative 37%, infrastructure with human habitat at negative 44%, and infrastructure with health at about negative 29%. Now we can see that food, water, vulnerability, and sensitivity form a highly interconnected cluster. Adaptive capacity correlates positively with many of these sectors. Now these results highlight interdependent vulnerabilities. Sectors like food, water, and sensitivity tend to rise or fall together. So since I wasn't able to kind of cluster the 20 countries to show these impacts, I wanted to create a heat map to better visualize the sector score for each country. Now each cell shows a scaled score, which is standardized by the row for the country sector pair. So the blue would be the below average vulnerability, and red is going to be the above average vulnerability. Now Bangladesh, Haiti, and Yemen appear among the most impacted countries, indicating a critical imbalance between exposure to climate hazards and the ability to adapt. Haiti stands out for a high environmental, which is about 0.88, and health, 0.85 vulnerability. We see this high adaptive capacity vulnerability spread kind of throughout. The heat map reveals a concentration of climate vulnerability in sub-Saharan Africa and South Asia, regions marked by limited infrastructure, high disease burden, and poor access to public services. This heat map complements a lot of my previous analysis by showing that these patterns can manifest country by country, and a lot of times these are shared, country by country, regardless of borders. So, in conclusion, this analysis reveals significant variation in vulnerability scores across sectors, with infrastructure, water, and sensitivity scoring lower in resilience compared to sectors like health and adaptive capacity. Using ANOVA, we confirmed that the differences in sector means were statistically significant, and post hoc Tuckey tests pinpointed which sector pairs differed most meaningfully, such as infrastructure versus adaptive capacity and sensitivity versus health. Correlation analysis further revealed strong positive relationships between vulnerability in key areas like food, water, and sensitivity, suggesting interdependencies that must be considered in future planning. The results support more targeted resilience planning, efforts to boost adaptive capacity, improve infrastructure, and reduce sensitivity could significantly reduce overall vulnerability. The analysis offers a statistical grounded foundation for policymakers and community stakeholders to make informed, data-driven decisions in addressing climate and infrastructure-related risks. Wonderful. Thank you for your time.